Hello everyone, welcome to 1-10 Guiding Notes on Significant Figures Math. This is part of Unit 1, Properties of Matter. So for the guiding question, how are the rules for significant figures different for multiplication and division versus addition and subtraction? And that's what we're going to look at. So review significant figure rules by answering the do now. And now we'll get to the notes. So for addition and subtraction, the major rule is that you report your answer to the same number of decimal places as the value that had the least number of decimal places. So we have two numbers here, and we're going to add them. Well, the number of decimal places in addition and subtraction determines the number of decimal places in your answer. So we have one with 3 decimal places and one with 1 decimal place. The 1 decimal place is going to determine that our answer can only have 1 decimal place. And so it must have that 1 decimal place. If it was supposed to be 0, you would still write the 0. Another trick to help visualize is to imagine that the digits that are not shown are not zeros, as you would treat them in math, but use question marks instead. So you would fill in question marks, and when you add them, these two are tagged with a question mark, meaning you can't use them. And then you would round after that to this number, because you can use only that first decimal place, the tenths place. The use of a question mark shows that both the 0 and the 6 are not known, because the 1.2 gram measurement is only known to the first decimal place, so it is not as precise as the other measurement. So you can't report more than the 1 decimal place in your final answer. If you were, you'd be reporting 3 uncertain or guess digits for the measurement, and that is not allowed. You're allowed 1. A common mistake occurs when you perform addition or subtraction with numbers that aren't known to a decimal place. Consider 1200 grams. This is only known to the thousandths place, and the trailing zeros are placeholders. You can write this in scientific notation to help you understand that idea, which is 1.2 times 10 to the, this is supposed to have a caret, 4th. Okay, so consider these two numbers. We line them up, but we notice that this one is known and this one is the one that's known, and neither one of these technically are, because they're not significant. And so when we do this, it tags the 8, 2, 0, and 1 with a question mark, meaning this is my last uncertain digit that I can keep, because anything extra I can't use. So then I would round to 14,000. So the question marks that I'm filling in tell me I can't have that number there. I have to make it a 0. And so the one that is right next to the first question mark is the one I will round. And in this case, I will round it up because it's 8. For multiplication and division, it's a little more straightforward. Report your answer to the same number of significant figures as the value that had the least total significant figures. So in addition subtraction, it's to the smallest number decimal place or like placeholder. For multiplication and division, it is smallest total significant figure. So when we look at this, we have 4 sig figs on this first number and 2 sig figs on this second number. So we're allowed 2 sig figs in our answer, which is, 1.6. If we look here, we have 4 and 3, which means 3 can be in our answer, so our answer has 3 sig figs. Normally, you perform all the calculations and then round once at the end. Okay, however, if you have to combine operations that use different rules, like addition with multiplication or subtraction with division or any other combination, you have to keep track of the number of significant figures. Okay, sometimes by doing that you can write an underline underneath the one that you can keep. So when we do this subtraction, we know that the tenths place is the one we can keep. So that technically makes this number 3 sig figs, but we don't want to round until the end. So we have 3 sig figs and 4 sig figs, which tells us that our answer has to be rounded to the 3rd sig fig because this is a division. Since this was subtraction, it was decimal places. Division, we do total sig figs, which would be 3 for the smallest total, and that would round to 5.20 grams per milliliter. So here we have our I do. So we're going to take our calculators and add these together. So 5.23, you can do this in your head too, but Ms. Bird does not trust her math skills this late at night. So 50.23 plus 123.722 plus 14.87432 is 188.82632 grams. I cannot keep all of those, so I'm going to look at my decimal places. I have hundredths, thousandths, and really far out there. Hundredths is the smallest number of decimal places, so I'm allowed to keep the hundredths. Looking at the 6, it tells me I need to round up, so my final answer will be 188.83 grams. Remember that if it's 5 and up, you round up, 4 and below, round down. So this would be my answer. Looking at the next one, I would do the arithmetic or math. So 2.3877 times 3.04 and write my total answer, 7.25860 centimeters squared, since I'm multiplying it. And then I look, I have 5 sig figs here and 3 sig figs here. Because it's multiplication, I do total. Smallest total. So 3 sig figs is my what I get to keep in my answer. So I'm going to count 1, 2, 3. I can keep up to the 5. The 8 tells me to round up. So my final answer is 7.26 squared centimeters. Scanning the QR code, complete the we do questions for both of these. Then in your notes, complete the you do. When you have finished all of that, answer the guiding question at the bottom of your notes. And if you are absent, you can upload to the Schoology assignment, or you can save it and turn it in when you return to class. Thank you, everyone.